I am Anil Kumar. Welcome to my channel and the website globalmathinstitute.com. I hope with the help of the videos and the contents provided, you have learned about the what moments are and how do we calculate moments. Here is very important practice test question. Now this question has appeared in past test papers and therefore should be very useful to you. In case you want to learn from me, you can always send an email on the address given here. The question is about tilting. So here's a quick reminder what tilting is. When a rigid body is on the point of tilting about a pivot, the reaction at any other support is zero, right? Question number 4 here is a uniform wooden beam XY of length 7 meters and mass 25 kg rests with 4 meters of its length in contact with horizontal surface as shown in the figure. So this length of 4 meters is on a table, you can say, right? A boy of mass 35 kg stands at Z, where x to z is 3 meters as shown in this figure, right? And then walks slowly towards x. So the boy is standing here. Let's say we have a boy standing here and starts walking in this direction. Now, part A of the question is find how far the boy can walk before the beam starts to rotate about z, right? So, about z means it starts tilting. Do you understand? Means it will just lift over this. In that case, you can see that the reaction at y will be zero. That's what we mean to say when we say reaction at any other support is zero. You get the idea of tilting, correct? Keep that in mind and then answer this question. Part B is find the smallest mass that must be placed at y so that the boy can just walk to x, right? So it has two parts. So I'd like you to pause the video, answer the question. So let us see how we are going to solve this particular question. We are given that the total length is 7 and therefore the midpoint will be at 3.5, right? So somewhere here we expect the midpoint, which is 3.5. Now at this midpoint, the mass of 25 kg will be there because we are assuming a uniform wooden beam. So we are going to model this as a rod. As a rigid rod. So rod means one dimensional. Rigid means it is not going to bend or something, right? So this is not going to buckle or bend. So the mass can be focused at 3.5 meters and it is 25 kg. Because of this, there will be weight of 25 g newtons. Is that clear to you? So that much is acting at a distance of 3.5 from x. Now we can clearly say that the how far the boy can walk before the beam starts to rotate about z. So when you're talking about the rotation about z, the other forces or the reactions will be zero. So we can now work at this particular point z itself. So you can consider the boy to be some distance away from z. So let us say this is the point where, let me use a different ink here, where it starts tilting. So the question here is how far the boy can walk before the beam starts to rotate. So let this distance be x. So from z, we are saying this distance is x, as shown in the diagram. Now, to find the answer, we'll consider the moments about z. Is that okay? So that should give us the answer. Perfect. So let us see how to solve this particular part of the question. So I think you have understood the concept. The mass being centered in 3.5 units, and therefore from z it is 0.5 meters, correct? So this distance of mass is 0.5. So distance traveled before tilting, let it be x. Now what we are going to do is find moment about z. So because of the boy here, whose mass is 20, boy's mass is how much? 35 kg. So that is 35 g. As far as rod is concerned, it is 25 g. So because of the boy, the moment will be counterclockwise. So this moment, 35 g times x, should be equal to the clockwise moment due to mass of 25 kg. So that is at a distance of 0.5. Is that clear? So that is how we can actually solve this question. G and G cancel, and we can further calculate the answer for x, which is basically equal to 25 times 0.5, which is half, divided by 35, correct? So that becomes the distance. So let's calculate. So we have 25 times zero point 0.5 divided by 35. That gives us 5 over 14, or approximately 0.357 meters. Is that clear to you? So that much distance the boy will move before it starts tilting. So we have rounded to three significant figures, right? So I hope this concept is absolutely clear, right? Now let's look into the second part of this question, which was find the smallest mass that must be placed at y so that the boy can just walk to x, right? So now what we are trying to do here is, let me again make this diagram so that we are absolutely clear of what we are trying to do here. So I'm making a smaller diagram this time. You can see that the support was to this side. We want the boy to walk till x. That means the net force will be at this point of 35 g, correct? The weight we already know is 25 g at the total length is 7 meters, so this is at 2.5 meters. Now we want to place some mass here. So let us say that the mass which we place here is m. So that will be mg, correct? So that becomes our diagram. We know these points are x and y, and the point here is z, which is 3 units from this place and 4 units from y. Is that clear to you? So that is how we have our diagram. Now we need to find what should be the value of m so that the boy can actually come to the whole distance as shown here, right? So to find this, we can find the moments about any particular point. So let's again find it about z itself. So in that case, we are finding moments about z. So let me highlight this point. Z here. Sum all the moments. So because of the boy weight, we have a counterclockwise, and because of the forces on the right, we have clockwise moment, right? So we can say that 35g times 3 should be equal to sum of the other moments, which is 25g times this distance of 3.5. It is so 0.5 plus, from m it is 4 units, right? So mg times 4. Is that clear to you? So this can lead to the solution cancelling g. The only unknown here is m. So the value of m can now be written as 3 times 35 minus 25 times 0.5 divided by 4. Let me write like this, divided by 4. Is that clear to you? So that becomes the mass. So let's do this calculation. So we have 3 times 35 minus 25 times 0.5. And we are going to divide this by 4 and gives us 23.125. So that much kg, correct? Now, tell me, when you round this, what should be your answer? We have to round it to 3 significant figures. Now, it's important. The condition here is that a boy of mass 35 kg stands at this. Oh, that is not the part. We have to now see part B, which is find the smallest mass that must be placed at Y so that the boy can just walk to X. So if the mass is less than the value which we calculated, the boy will not be able to walk till the end. Mass has to be more than this value. And therefore, the answer will be what? So answer will be minimum mass is 23.2 kg when we round to 3 significant figures. Do you understand this? Very critical step. If you round it to 23.1, you'll lose 0.5 marks because in that case, the boy will not be able to go to X complete length. Perfect. So because there is a lot of calculation going on here, here is a neat and clean solution for you with the question. So in this question, we basically had two parts, and that is to say that in the given scenario, find the distance through which the boy could walk without tilting, right? And then in part B, we have placed some mass here so that the boy can go all around. And that mass was 23.2 kgs as explained. So I hope the whole explanation is absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my channel, that will be great. And in case you have any doubts, you can always send an email on the address given here. So with that, we conclude our practice test session on moments, and I hope that gives you a good perspective of this particular topic. You can always share your questions. We are there to help you out. Thanks for your time and all the best.